Hey guys, here's what I want to talk to you about really quickly. I want to talk to you about the classification of MatterLab and how you're going to do it. So, first thing you're going to want to do is you're going to want to go to Schoology and you're going to want to download the Word document, classification of matter flowchart and data table. And you're going to want to download the PowerPoint classification of matter materials. So, here's how this is going to work. What I have is a picture of a bunch of different types of materials. And then each picture, for example, the first one is a picture of glue. That corresponds to vial number 1. The second picture of milk of magnesia corresponds to vial number 2, and then kind of so on and so forth. There's a total of 12 pictures. They go in order from picture number 1 to picture number 12, vial number 1, vial number 12. Now, what you're going to want to do is you're going to want to, for each picture, so for example, for glue, you're going to want to tell me, is it matter or is it energy? That's kind of 1A and 1B, so pick one of the ones, if that makes sense. Then you're going to want to tell me, is it a heterogeneous mixture, is it a homogeneous mixture, or is it a pure substance? So you're going to either write an X in 2A, 2B, or 2C. So have 1x in one of the number 1s and 1x in one of the number 2s. Lastly, you're going to tell me if it's a suspension, a colloid, a solution, an element, or a compound. Pick one of those 5 boxes and put an X in there. Again, this is for glue. Now, you might be wondering, how do I know? What you're going to do to help you with that is you're going to use the flow chart over here. So this flow chart takes you through, you start at question 1, and you ask yourself the question, does it take up space and have mass? Unless it's energy, which there's not any pictures of energy, the answer for this question is going to be yes. So you follow the arrow, and that tells you, hey, for question number 1, or for data table number 1, put a check mark next to 1A and leave 1B blank. Then you're going to move over to the 2s. In order to get to 2s, you're going to have to answer question 2, and you might have to answer question 3. Let's go through them. Question number 2 says, does it have a variable composition or is it uniform throughout? And then if you say it's variable, you move on to 2A. If you say uniform, you move on to question number 3. Now, you might be wondering, what does that mean? Variable composition or uniform throughout? If something has a variable composition, it's going to look different. If something is uniform, it's going to look the same. So another way of saying this would be variable composition would be saying, does it look chunky? And then uniform throughout, does it look smooth? So, for example, it looks like glue here. This looks to be pretty much the same throughout. Versus if we look at something like the aquarium gravel seems to look different. All these things have different colors, different sizes, different shapes. They're not the exact same color, size, and shape. If something's the exact same color, size, and shape, we're thinking uniform. If it has different colors, sizes, and shapes, we're thinking variable. Let's say we're dealing with aquarium gravel. Then we move on to question 3. Do the particles settle out after being shaken? This is only really good if the substance you're talking about is in a solution. So if you're dealing with something like salad dressing versus something like milk, those would be good things to look at, like do they shake up, do they settle out after you shake them up, or do they not? So question 3, it might be hard to determine suspension or colloid, in which case you feel free to leave that blank. Feel free to not answer that question if it's not in a solution. Let's say you said uniform, which you might have said for glue. The next question you're going to ask is, can it be separated physically or chemically? Ways to separate things physically would be filter it, either with like a coffee filter or even like a Brita filter. You might boil it and it might separate that way. Or if you heat it up or cool it down, it might separate that way. Chemical means would mean you'd have to do some sort of reaction to separate the particles. If you can only separate it via chemical means, this means you're dealing with a pure substance. A good way to double check if you are dealing with a pure substance is you'll notice next to each name, some of them have chemicals. Remember, chemicals is another word for pure substances. So, if you see a chemical formula next to anything, think that's a pure substance. If you say physical, that means it's a homogeneous mixture. If you say it's a pure substance, last question is it on the periodic table? Remember, there's a way to tell if something's on the periodic table or not. it'll have one capital letter, and that'll just be an element. An element only has one capital letter. A compound has more than one capital letter. So that's everything I have for you guys. Try your best on this. Try and fill out the data table as best as you can. I can see how some people could argue for more than one correct answer. So if you feel like there's more than one correct answer, just take your best guess and know that I won't take points off for you taking your best guess. Also, we want you to write down physical properties of each material. Tell me its color, tell me its size, tell me its shape, tell me if it's a solid, liquid, or gas, that sort of thing. And then don't forget for each substance to write down what the substance actually was. So substance 1 should be glue, substance 2 should be milk of magnesia, substance 3 should be vinegar, and so on and so forth. I hope this helped. I hope you guys have a great rest of your day and happy lab time. Take care.